Hello everyone, I'm back with my next lesson. So today we have 10-2. So 10-2 is about verifying identities. So you have, it's verifying trig identities. So basically what's going to happen is like you'll see an equation. So when I say verify, it's basically mean that you're proving one side equal to the other side. So sometimes it seemed like last section, but before it was like, okay, you just have an expression, you're just rewriting, right? And you didn't know where to stop. So this is something good about verification because you do have the goal. You know where to stop. So you just have to pick one side, or sometimes you can pick both sides. You can start simplifying and make it equal to each other. So once both sides are equal, that's where you need to stop. So like the first example, again, don't forget to have those fundamental identities handy all the time. So this is what I have in the first example: secant squared theta minus 1 over secant squared theta, and you need to make this equal to sine squared theta. How? I'll show you two different ways. So pretend, first one, let's say what I see is secant squared, which could be replaced with tangent squared theta plus 1 based off one of the Pythagorean identities. So let's say if I replace this secant with tangent squared theta plus 1, so I replace secant with that, I still have minus 1 there. And then over, it's secant squared theta. Okay, now let's try simplifying. One's going to get canceled out. So you have tangent squared theta over secant. Try simplifying more. So tangent squared theta, so based off quotient identity, tangent is equal to sine over cosine, just because tangent has square, so I need to carry that square. Okay, this whole thing over secant square, which also can be written as 1 over cosine square based off reciprocal identities. Okay, one more. So you have fraction divided by another fraction. So you can just say multiply by the reciprocal of the bottom one. So I could rewrite this as times it by the reciprocal of the bottom one. This is what I have. So cosine is going to get canceled out. So sine is my answer, which is equal to the other side. That's one way to attempt this problem. Or another way could be, what I see is this is one big fraction. You can even split up into two different ones. Like I could do secant theta over secant theta, and I have 1 over secant squared theta. Secant divided by secant, that's going to get canceled out. So I have 1 minus. So 1 over secant square is equal to cosine square. So later on, 1 minus cosine square is equal to sine squared theta, which is still the same thing. Here you go. So either or, it's fine. That was my first example. So I'm on page 636, and right now I'm about to do example 2. So you can follow along if you want to. So this is example number 2. I have 1 over 1 minus sine, 1 plus sine, and you need to prove this equal to 2 times secant squared theta. Okay, what I see two different fractions. So basically what happens is if you see multiple fractions, combining fraction is the easiest way you could do. So I'll take the LCD, which is 1 minus sine and 1 plus sine. First, I would multiply by 1 plus sine. Second, I would do 1 minus sine. Okay, so 1 plus sine theta plus 1 minus sine theta. Okay, let's simplify. Sine is going to get canceled out. So you have 2 over 1 plus sine and 1 minus sine. If you look closely, isn't it that difference of 2 perfect square, which could be simplified as a square minus b square, which is a square means 1 square minus b square is 1 minus sine square. Here you go. Now, 2 over, what's 1 minus sine square? Again, go back to your identities. That's equal to cosine squared theta. Almost there. Now, I'm almost there. So I already have 2 in my answer. The only thing that's missing is secant. But if you look closely, isn't it, if I rewrite this, it's 2 over, or I would say 2 times 1 over cosine square. Isn't it? The same thing. Which is later on equal to secant square. So my answer would be equal to this. There you go. Okay, a few more. So example number 3. I have tangent squared theta plus 1. And I have cosine squared theta minus 1, and it's equal to negative tangent squared theta. You could distribute if you wanted, but what I feel like, I already know tangent squared theta plus 1 is equal to secant squared. Okay, cosine squared theta minus 1. That's not one of the identities. The identity we have, it's 1 minus cosine. So in order to apply that identity for this expression, you could even factor out a negative if you wanted. Or you could even write this as this. Either or, it's fine. Or you could rewrite, I would do negative 1 plus cosine squared. Then I would factor out a negative. So this would become 1 minus cosine squared. Here you go. All right. Isn't it 1 minus cosine squared is equal to sine? And then it would get multiplied by this negative here. All right. So this is, we are trying to prove this equal to this. Okay. I could do a few more steps. Secant, I could simplify as 1 over cosine squared. Sine would stay the same. I would keep this as it is. Now, if I put it together, isn't it would be negative sine squared theta over cosine squared theta, which is equal to negative tangent squared theta, and now I just verified the identity. I proved both sides equal to each other. So done with this. Today's lesson going to be a little bit long. Why? Because I still have 2 more examples to go over. So let's look at example number 4. Tangent x plus cotangent x, and you need to make it equal to secant x and cosecant x. Okay. How? Again, you can pick one of the sides, start simplifying, and prove it equal to other side. Doesn't matter what side you take. You can take left or right, or just pick the side you feel like you can do more stuff on. All right? So like this one here, I feel like I could do, it's pretty much the same amount of steps you could do with both. I'm just going to pick the left side. So tangent can be written as sine over cosine. Cotangent is cosine over sine. Okay, I see 2 fractions. I would combine. So cosine and sine. Take LCD. So I would multiply by sine here, cosine here. So this becomes sine squared, cosine squared. Again, fundamental identities. The top expression is equal to 1. Okay, this is what I have. All right. I could still make it equal to other side, but again, let me show you another way. I'm just going to stop here. Let's just say, pretend I don't feel like moving on. I feel like there's nothing else you could do. So I could just stop there, and then you can start simplifying the other side. Like here, secant can be written as 1 over cosine. Cosecant can be written as 1 over sine. Since I'm not adding, so there's no point of doing LCD. So I can just put it together as, isn't it this is same as this? Here you go. So that's just another way. You can work with one side or you can work with both sides. So whichever way is easier, you could do that. And almost there. One more example. So it's example number 6. So bear with me. Last example. So I have cotangent squared theta over 1 plus cosecant. You need to prove this equal to 1 minus sine over sine. Okay, let's see what I could do with left side here. Cotangent, you could do cosine squared over sine squared. You could do that, or one of the fundamental Pythagorean identities. So cotangent is equal to cosecant squared minus 1, and it's still over 1 over cosecant theta. Okay. Now, if you look closely, the top expression is nothing else. It's difference of 2 perfect squares, which could be written as cosecant minus 1, cosecant plus 1, and it's 1 plus cosecant. Isn't it 1 plus cosecant is same as cosecant plus 1, right? So I could cross these out, and so far what I have is I'm left with this expression, and that doesn't look like other side. So I'm just going to stop here. Let's try simplifying other one. Okay, I see 1 fraction. And for 1 fraction, you could just split up into multiple pieces. So I could rewrite this as 1 over sine, sine over sine. 1 over sine is cosecant, sine over sine is 1, which is same as this. Here you go. So last, I would repeat, let me repeat this information here. So basically, you need to make one side equal to other side. Sometimes you need to work with one side and try simplifying. And once you have something equal to other side, stop. You are done verifying. Or sometimes you could pick both sides, start simplifying, and once you get both sides equal to each other, that's all you have to do. All right, so yeah, this is pretty much all. So if you have any question, please comment and then I'll answer it, or soon we'll have a Zoom meeting and I'll take all your questions. All right, thank you guys. Thank you for watching. Bye.